All right, so let's get moving here. My name's James Denton. I'm a principal architect at Rackspace, OpenStacker. Um, we're here to talk about Ironic, and I apologize for the generic title that came up, about a month ago, but I only started working on this content in the last week, so it'll diverge a little bit from the generic rapid bare metal provisioning to something a little more specific about how Rackspace is transitioning from an in-house uh, bare metal deployment system to an Ironic-centric bare metal provisioning system. As part of that, we'll talk about spine leaf architecture as well as virtual media. All right. So when it comes to servers, Rackspace provides a lot of customizations. We have different business units with different requirements. Often those vary from what actual customers want to implement. So we have hundreds of SKUs that describe different CPU, RAM, hard drive combinations. When a server build request comes along, that server is actually physically opened up and modified to meet the requirements of that particular deployment. Then it's racked and cabled according to spec. The logical network environment is built out in in-house tooling called IP Commander and Environment Manager. And then once all of those pieces are in place, our DC team can kick off a deployment of an operating system with some level of automation. This system was originally built in the kind of late 2000s, early 2010s, before Ironic was even on the roadmap. The golden age of PowerEdge 2950s, right? Um, our internal system, known as Core, has a state machine that triggers kick in the rack, and then based on the given state of the device, will transition into another state like racked, ready, cabled, ready for kick, etc. Boots from a RAM disk, much like Ironic does, determines what node it is by its provisioning MAC address, and then drops the OS based on the SKU associated in Core. Some advantages of this in-house deployment system is that it's tightly coupled to our internal systems, which allow these configurations to be described in tools easily understood by sales, account managers, and other people in charge of building those systems out. Our RAID configurations can be described in Core, as well as things like operating systems, Linux, Windows, VMware, etc. The disadvantages, as you see, are that it's very tightly coupled to our internal systems. That means that Rackspace hosting workloads in our own data centers as well as customer data centers, we can't easily port this kick deployment system into another location. A lot of assumptions are being made as part of this that Core, IP Commander, Environment Manager, plus a dedicated 1 gig provisioning network are all going to be available wherever you deploy this. And that's not really realistic. So as we've grown out of Rackspace DC, it became apparent that a new deployment strategy would be necessary. So right now, some of our teams deploying offsite might leverage, ISOs or Ubuntu's MAS or Cobbler or some other system that's easy to stand up. So enter Undercloud. Undercloud is developed using modern tool sets based on OpenStack Helm, Ironic, Kubernetes. I can't do it justice by trying to explain the architecture, but the purpose of Undercloud is to be a lean but opinionated provisioning system that supports specific compute, network, and storage features that provide bare metal provisioning for an entire data center rather than as a sidekick to virtual machine workloads. And what I mean by that is that our data center should be treated like a cloud with hardware profiles that lean towards consistent configurations rather than one-offs. Think roll-in racks of pre-cabled gear that are all homogeneous versus, a rack and stack piecemeal strategy. This is, essentially the foundation of what we offer our customers, VMware, Oracle, whatever. The idea is that you'd be able to deploy any image on this box, much like you would within an OpenStack ecosystem. And by reducing the number of possible configurations of bare metal flavors, we can simplify and better operationalize deployments and ongoing maintenance and significantly reduce the deployment times. The purpose of this talk, Ironic's doing the heavy lifting here, including all the server provisioning, some RAID and firmware updates. We're using Nautobot, which is a fork of NetBox, if you're familiar with that, as a source of truth that feeds OpenStack the desired outcomes, but they can also manage network switch configurations outside of what Neutron might be able to do with the ML2 plugin. We've written a custom ML2 plugin, though, that can tickle switches to change VLANs, create port channels, modify trunks, etc. Very specific to our Cisco-centric network model, but it needs to become more agnostic because we operate in other vendors' play spaces like Arista, Cisco, and others. Some advantages of this approach: we get to keep RAID support still that you can describe within Ironic. There are some caveats there. Not everything can be implemented maybe with the Redfish APIs, but some vendors do have extensions to Ansible, which I'll get into that a little bit later. We can still support multiple operating systems like Windows and Linux and basically anything that exists as a QCOW raw image. It's more easily portable outside of Rackspace DC. All you have to do is implement the reference architecture, which is a small cluster of Kubernetes nodes essentially running this stack. So deploy from repo and go. And being that it's based on Ironic, there's a larger community of users with similar use cases that are all contributing toward a common goal. So as we think about using OpenStack at a foundational level, we need to be able to model and map logical resources to physical resources. Neutron and Ironic already provide most of this by the way of networks, subnets, ports, Baremetal ports, etc. So some of the things that we need to model in this architecture are physical edge devices. So as we're deploying Baremetal nodes for a tenant, and this is the multi-tenant cloud essentially, we want to use a physical gateway device. And for Rackspace, that's going to mean something like a Palo Alto firewall, Cisco Firepower, something along those lines. And as we look at trying to describe everything logically within the confines of Neutron, the direct correlation there is like a Neutron router. But we don't want to implement a software-based network namespace or an OVN router. We want there to be an L3 Neutron plugin that can actually maybe talk to those physical devices to configure the networks, configure potentially firewall rules, everything you might be able to do with a virtual router just in hardware. For the Baremetal nodes themselves, we need to be able to describe their networking configuration. So a Baremetal port has a one-to-one correlation to an actual network interface on that server. So if a NIC has 2 ports, there's a Baremetal port for each interface. Here, that's an R760, 4 NIC interfaces, 4 Baremetal ports. And then for the networks themselves, in a spine leaf especially, we need to be able to describe that physical network connection from the server to its switch. So here I have 3 leaf switches. I have nodes that are multi-homed across multiple leafs, and so each of those network connections has a corresponding physical network. So as I mentioned kind of in the first slide, our data centers themselves are transitioning from a core aggregator model to a spine leaf model. We're using BGP, EVPN, and this introduces new and exciting ways of breaking things within OpenStack. Our previous architecture saw networks treated as single layer 2 segments spanning multiple top of rack and aggregation switches, complete with spanning tree and scaling limitations. And in Neutron, these connections from a hypervisor or a Baremetal compute to the switch might all be reflected as FizzNet1, right? So there's an expectation that all the VLANs that you described in OpenStack would all be available to every host in the environment, which isn't necessarily true for a spine leaf architecture. So in the new world, we see the leaf as the layer 2 boundary with multiple segments representing a single network. Routing in the fabric is used to connect an instance in the tenant network between cabinets, as each instance is on a different subnet in a different layer 2 domain. But logically, though, from a user interface standpoint, that network is the same network. The connections from the hypervisor to the switch will be labeled based on their location. So maybe FizzNet1 for leaf 1, FizzNet2 for leaf 2, etc. so that the appropriate subnet is applied to that interface when you deploy the machine. The technology or the feature within Neutron that provides this functionality is known as router provider networks, and subset of that being network segments. Cool. So Ironic can use the physical network attribute that I just described and apply it to a bare metal port to determine which segment of a particular network applies to that interface. So in this example, and I'm sorry for the text there, the spacing got kind of janky, but Baremetal 01 has 4 physical interfaces able to 2 switches configured in a VPC using LACP. The physical network applied to those ports reflect the switch they're connected to, and the physical network labels must be defined in the ML2 configuration of Neutron server, the API service, if you're familiar with that. Pixie, in this case, is only applied to the first 10 gig interface. We have port groups that are defined that help describe bonds, essentially, for that host. In this example, they're configured as LACP bonds, but you can also do active backup. And the neat thing is that the better you describe the connections from a server in Neutron, the more automation that you're able to apply. Cloud Init is aware of the port groups and the network information. So if we were to do a provisioning exercise right now, and all of this was described here, the minute your machine is provisioned, you should be able to log into it. The port channel configuration would already be there in NetPlan. It's pretty slick stuff. And here's more or less, oh man, that's really bad. An extension of what I just described. So this goes into the actual network show and subnet show and segment list to show the relationship between a network and its given segments, and then from those segments to their respective subnets. If a user were to deploy against what this is like, this is the Ironic provisioning network in this example, to first bootstrap and deploy a host, based on that server's bare metal port link local information is going to determine which segment it should be using. So Ironic will apply an IP address from the right subnet to get you on the network. Now, this is YAML vomit, right? But Undercloud is under development right now. And it's not something I can easily use and demonstrate. So, but in order to build automation, I think it's important to go through the exercise manually to determine what that workflow needs to be so that you can properly automate it. So one of the things I've done is, created a set of Ansible workbooks or playbooks, sorry, to go through the process of enrolling nodes, cleaning nodes, setting, Pixie boot interfaces and all of that. Get it to the node to a point where I can actually provision against it. In order to do that, I constructed 2 inventories, a bare metal node inventory, and this is information that would live in something like Nautobot, where I'm able to describe the physical network connections there to the respective leaf. I'm able to define which bond those connections are a member of, able to define the RAID configuration, the Pixie NIC interface, and all of that that's going to be necessary when I have Ironic ingest this node. In this example, these are 2 sets of different Dells, R760s and R740s, that have a couple of different GPUs. And, every node chassis is going to be a little bit different. For an R760, you can see like the first 10 gig interface is a NIC integrated 111. The other one's NIC slot 411, and that's integrated versus PCI. But for a given set of nodes and a given set of in a rack, we expect it to all be the same. This just an extension. This is the bare metal instance inventory. So this is something that a user might construct. They wanted to deploy a GPU or a compute with a P40 or an H100. Those are the IP addresses that they're going to apply. The end user has no idea that that node has bonds configured necessarily. They don't obviously know what those interfaces are, and they don't really care. They just want to apply an image and a key, maybe some Cloud Init data that could also live in here as well. Now, that workflow I described, my inventory exists. I use the playbooks to enroll the Baremetal node. Also configures the RAID as part of an Ironic cleaning exercise. In my case, though, because I wanted hot spares, I don't recall that that's something that the Ironic um, cleaning RAID configuration can actually do. But there's going to be some things like that you might come across. And then the redfish inspection. That's I guess, out of band inspection method that allows Ironic to talk to the node and determine at least network information, so network interfaces that will then become part of it automatically creates bare metal ports based on that information that contain the MAC addresses that I can then cross-reference to my inventory to be able to construct the bonds. Set the bootnik on the Dell side that allows the node to not cycle through all 6 network interfaces looking for an IP address. And also set on the Ironic side so that Neutron isn't constructing DHCP information for 6 interfaces I'm not going to use. Then run a full-blown inspector-based introspection so that I can determine more information about the node, like storage capabilities, LLDP information, and all that will also become helpful when configuring the bare metal ports so that Neutron can actually talk to the switches to configure the right switch ports. Then create the port groups, so the bundles or bonds that I described in that bare metal inventory. Again, cross-referencing interface names to what is in the inventory by MAC address. And then lastly, create the bare metal instance. So all of this has an assumption, especially in a spine leaf model, that you would be using something like a DHCP helper on your leaf switch so that your PXE requests can be answered and you can actually get to the Ironic API. That's not terrible with Neutron DHCP agent and OVS. When you're using something like OVN, it becomes a little more difficult to implement. But what I found was that virtual media boot helps really solve that problem because you eliminate the need for DHCP completely during provisioning. When you boot from virtual media, Ironic Conductor will actually construct an ISO that contains the image, contains the RAM disk and the kernel. So you're booting from via the BMC. It's downloading the ISO from Ironic Conductor or Swift or some other location. And then Cloud Init on this ISO will actually configure the interfaces inside that running OS. So you don't need DHCP at all. You just need routing capabilities to get back to the Ironic API conductor to be able to tell it you're done, right? Now, one of the downsides potentially is your BMC is usually 1 gig, hopefully not lower, and your provisioning network might be 10, 25, 40, something a little bit faster. So this could be a little bit slower process. But I found its complexity is a lot less than something like your traditional PXE DHCP process. One thing I did recently try that I don't know if we'll use in production would be boot from volume, right? Because you eliminate the provisioning network completely. Julia says, no, don't use boot from volume, but it does work. But okay, yeah. So going upstream, right? So Kevin, I think, mentioned this in our keynote this morning, but Rackspace having taken a back seat for a few years, we are embracing OpenStack wholeheartedly. And Ironic has never left Rackspace. Our on-metal product that we still sell on our public cloud today is based on Ironic. We deploy with all of our private clouds. And Doug Goldstein, now a reviewer of Ironic stuff, like we're really invested in this. Everything for Undercloud development is actually going upstream as well. I don't have a full QR code or links here, but come by the booth later if you want. We can give you some URLs. It's called Understack, I think, because we're really good at naming things as well. And Genistack, which is our OpenStack Flex open development stuff, is also available. Thank you. Any questions? Yes, sir. So, sure. So the question is, we're using the redfish inspection as well as the inspector-based inspection. And is the data sort of merged, I guess? So in our case, or in this case, simply for the development towards Undercloud is I'm using the redfish inspector to get a very base level understanding of the node, mainly for the NIC interfaces. And so it'll automatically create the Baremetal ports. It is not as thorough as a inspector-based inspector might be, but it's going to be improved by upcoming work, right? So the inspector inspection actually overwrites the other one, but I need the other first to be able to do some other pre-provisioning things. Yeah. And I got one more question here. Okay. Oh.
It's a short question.
Oh.
That's really interesting. What does Nautobot do that Netbot?
So that's a good question. I think the idea, so yeah, I guess the team that was putting this together decided that the community around Nautobot, they thought it was composed somewhat of ex-Rackspace employees as well. So maybe a little more inroads into some decision making there. And it seemed like they may be more receptive to sort of the direction that we wanted to go with the product. You know, it's been a year at least since that started. I'd be really curious to talk to the team to figure out if that was a good decision, bad decision. Maybe they're all in, can't move. You know, I don't know. But the idea is to eliminate technical debt from our other stuff. We don't want to build new tech debt either. But yeah, I don't know.
Other questions? Hang on one second, Jonathan.
Yeah, so how very loud. How do you have Neutron talking to your switches? Is that with the generic switch driver?
So in this case, this is not the networking generic switch driver. It's a driver that Rackspace has written for
Okay.
this, but it's doing very similar things.
Okay.
I don't know if it's part of our upstream repo or not, but I know NGS was sort of a baseline for that.
Right.
Yeah. Now, I do think that there are some scaling limitations to NGS, and I'm not sure if the team's worked through those yet or not.
Got it. Thank you.
Yep. Yes, sir.
Hang on one second. I'm coming. Should have worn my workout clothes instead of a vest.
Hi, are you using Nova to manage Ironic, or are you using Ironic directly?
This is Nova managing Ironic.
Okay.
Yep.
This is great. We probably have time for one more if anybody else has a question. All right, this time I'm going to get to you before you.
Right. So I guess my last question here was, because you're no longer having a shared layer 2 domain between racks, is I guess in this new model, is this you're not able to offer layer 2 connectivity, or do you have some other mechanism if a customer requires layer 2 connectivity?
I mean, we would have some other mechanism if they require it. And you can use something like EVPN, I guess, to help bridge that, or we could just make it the same VLAN in both places, right, and use BGP to help that MAC address CAN table stuff. But yeah, it's not something we want to go out of the gate with. We really want to try and standardize on this model first, but there are going to be workloads that maybe aren't necessarily compatible with this. We'll have to figure out a solution for that.
Great. Let's thank our speaker. Thanks so much.
Thank you.